This is OwlUp, where learning happens in minutes, not hours. For a deeper journey, explore all our courses at owlup.co. Now, let's dive in. Welcome to Chapter 1 of our series, How AI Actually Works, the Complete Picture. In this episode, titled, What is AI? Cutting Through the Hype, we're going to break down the basics of artificial intelligence and help you understand what it really is, beyond all the buzzwords. So, let's dive in. Right now, your phone quietly runs more AI in a day than most labs did in the early 2000s, yet it still can't truly understand you. In this episode, we'll step into that gap between dazzling tricks and real intelligence and explore what's actually going on. If so much of what we call AI is still basically pattern spotting software, why does it suddenly feel like the world is tilting around it? Part of the answer is scale. More data, more compute, and more money than at any other point in tech history are all colliding at once. In 2022 alone, companies poured tens of billions of dollars into AI projects, everything from supermarket demand forecasting to drug discovery pipelines. Yet most of this money is chasing a very specific kind of system, narrowly focused models that are ruthlessly optimized to do one thing well. Your streaming service doesn't understand movies. It crunches your behavior and millions of others to make a bet on what you'll click next. In this episode, we'll pull apart those bets and look at how they're reshaping products, jobs, and expectations, often in ways the marketing gloss never mentions. Under the buzzwords and glossy demos, there's a quieter shift happening. AI is turning once static systems into moving targets. Search results rewrite themselves based on who's asking. Prices on flights or rides adjust in minutes. Even spam filters subtly change what lands in your inbox. That fluidity makes AI feel almost alive, but it's really the outcome of models constantly updating their bets as fresh data comes in. This matters because when software can adapt at that speed, the old assumptions about set-it-and-forget-it technology start to break, and with them, our sense of what's predictable. If you strip away the branding, most of what's called AI today falls into a few concrete buckets, all variations on the basic theme of learning patterns from data. One big bucket: systems that turn raw sensory data into structured guesses. Image classifiers that label an X-ray, speech models that turn audio into text, object detectors in cars that flag pedestrians and traffic lights. They don't see or hear in any human sense. They transform pixels and waveforms into probabilities about what's there, fast enough to be useful. Another bucket: systems that predict what comes next. Language models like GPT, code assistants, autocomplete in your email. Under the hood, they're all trained to continue a sequence. Given a history of words, clicks, or actions, they select the next token or move that best fits the patterns they've seen. With enough data and parameters, those next-step guesses start to look like planning or creativity, even when they're not. Then there are decision and control systems. Think of recommendation engines that rank which post you see first, fraud detectors that flag a transaction for review, or routing models that decide where delivery drivers should go. These often use reinforcement learning. The system tries actions, gets a reward signal, a click, a successful delivery, a blocked attack, and slowly nudges its behavior toward higher payoffs. What ties all of these together is optimization. Someone chooses an objective: minimize delivery time, maximize watch time, reduce error rate, and the system reshapes itself to push that number in the desired direction. Change the objective, and you can radically change the behavior, even using similar underlying techniques. This is where the hype creeps in. From the outside, a model that nails a medical image diagnosis or writes a convincing paragraph can look intelligent in a broad human way. But move it a bit off distribution, different hospital, different slang, different incentives, and its competence can collapse in ways that reveal how narrow it really is. The stakes rise as these systems get embedded into feedback loops. A hiring model trained on past employees starts to influence who gets hired next, which then becomes training data for the following version. A content recommender shifts what people see, which shifts what they click, which reshapes the model's sense of normal. Without careful checks, the system isn't just predicting the world,
It's quietly helping to create the world it expects.
Think about the last time your Maps app rerouted you mid-drive. Underneath that tiny turn arrow, multiple AI systems are negotiating. One forecasts traffic, another estimates arrival times, a third weighs accident risk. None of them knows why you're in the car. They're just optimizing overlapping goals that occasionally conflict with what you actually want, like a slower but less stressful route. In a hospital, similar layers show up in less visible ways. One model prioritizes which cases a radiologist sees first. Another predicts no-show risk. A third suggests staffing levels for the night shift. If the staffing model is slightly off, waiting rooms swell. That, in turn, changes the data future models learn from. You don't need a giant tech platform to see this stacking effect. A lone developer can stitch together off-the-shelf vision, language, and decision models into a support bot that recognizes a product, pulls a manual, drafts a reply, and routes hard cases to humans. Each step narrow, but the chain surprisingly capable. AI systems don't just sit in apps. They start to tug on institutions. When a city uses models to time buses or predict floods, rules about who gets served first quietly shift. Think of budgets as recipes. Once AI enters the kitchen, ingredients get rearranged. More sensors here, fewer staff there. The real inflection point won't be one super AI, but millions of small, opaque optimizations accumulating faster than laws and norms can keep up. As the buzz grows, the real skill isn't coding models, it's learning to interrogate them. Treat every smart feature like a new coworker. What evidence is it using? When does it fail? Who's double-checking its work? The more fluent you become in asking those questions, the less AI feels like a mystery, and the more it becomes a tool you can actually steer. Try this experiment. Pick one everyday task you do on your computer, like summarizing a long article, drafting an email, or planning meals, and do it twice, once yourself, and once with an AI tool like ChatGPT or Gemini. Time both versions, then compare. Which was faster? Where did the AI get things wrong, miss nuance, or surprise you with something useful? Jot down 3 specific differences you notice, then decide one clear rule for when you'll use AI for this task, and when you'll deliberately avoid it. This was OwlUp, your daily step forward. To keep learning with structured courses and more insights, go to owlup.co. Until tomorrow!